right, hi guys. We didn't quite get to this question in our last lesson, so we're going to do this one really quickly, and then I'm going to get you to move on with the rest of the lesson for today. So I just wanted to show you this example. This is on page 22 in your sign numbers packet, the brown ones, the sign numbers part 2, so make sure you're on that page before you continue to watch this video right now. It says drilling down, and it says a water well drilling rig has dug to a height of negative 60 feet. So a height of negative 60 means it's below ground level, so it's down in the ground. And it's a drilling rig, so that's what it does. It's meant to dig. So after one full day of continuous use, well, how long is one full day? What are we assuming? One full day is 24 hours. So in 24 hours, it has dug negative 60 feet. So assuming the rig drilled at a constant rate, assuming it was going at the same speed that whole time for the whole 24 hours, what was the height of the drill after 15 hours? Well, 15 hours isn't quite one day, so it definitely wouldn't have been as low as 60 feet, but let's see if we can figure that out. So can we use our formula that we know when we're talking about distance and time and a constant rate here? I'm assuming we want to use dirt, D equals RT. Do we know enough information to do that? Let's see. If we wanted to figure out what was the height of the drill after 15 hours, we'd want to figure out the 15. Oops, not there. Goodness, Mrs. Selectman. We would want 15 hours to be the time. I'm going to rewrite it over here. D equals RT. We'd want to figure out the time, and it's asking us what's the height. It's asking us for the distance. We wouldn't know that. So we must be able to find the rate for this one. How would we find the rate with what we know over here? We know it went negative 60 feet in 24 hours. Could we use that to figure out the feet per hour? Isn't that what a rate is? So what would be the feet per hour? Negative 60 feet for 24 hours? Can we simplify that? Can we figure out what that is? Well, we know it's going to be negative because a negative divided by a positive is definitely a negative. We could simplify this fraction first. We could turn it into a mixed number first. I'm going to ask myself, how many times does 24 go into 60? So I think it goes in 2 times, which would be 48. With how many left? 48 plus 12 would get me 60. 12 24ths left. And I can tell that 12 24ths is a half. 12 is half of 24. So I could divide both of those by 12, and I would get this to be 2 1/2. Now, I know a negative divided by a positive is still a negative. So negative 2 1/2 feet per hour. All that work was to find the rate. That's how fast that drill is going. Negative 2 1/2 feet every hour it's drilling down into the ground. So if I want to use my formula over here, could I use that as my rate? Yeah, and I probably am just going to write negative 2.5 maybe. I'll write negative 2 1/2. Wow, I really didn't give myself very much room there. All right, I might even do that again. Negative 2 1/2 times 15. All right, so looking at this, could I do negative 2 1/2 times 15? Well, we know a negative times a positive is going to be a negative, and that makes sense because my distance would be into the ground. It should be down below ground level. It should be negative. And I've got to do 2 1/2 times 15. Well, I can do this a couple ways. Could I do what's 2 1/2 times as much as 15? We could do what's 2 times 15, twice as much as 15, and then a half of much as 15, and then add it together. What's 2 times 15? That would be 30. What's half of 15? 7.5. So 2 1/2 times as much would be 30 plus 7.5. So we could get the answer that way, 37.5. If you don't see that, if you don't like breaking it up and doing it like that, the other way to do it, and if it's not as nice fractions, the other way to do it would be to just use fractions. I'm going to do it over here. If you had 2 1/2 times 15, I could make this into an improper fraction. 2 times 2 is 4, plus 1 is 5/2 times 15, and we talked about how do we make that into a fraction? 15 over 1. All right. So then we're going to make this 5 times 15. Okay, I got to think a little bit more about that because I don't have it memorized. 15 times 2 would be 30, and then another 30 would be 60, and then another 15. That's got to be 75. Or I could do that work off to the side. And then 2 times 1 is 2. So half of 75, that's another way to get 37.5. So a couple of different ways to do this, but they were all using this idea of rate times the time. So that had a lot of work all into one problem. There was a lot going on there. You had to find the rate, and then you wanted to use the distance formula to find the distance right there. Okay, one last question on this one, because I do definitely want to practice a little bit of long division with you here, and with decimals. It says, if this rig has been running constantly, and it's currently at a height of this, negative 147.5 feet, how long has it been running? Okay, I'm going to write my distance equals rate times time. It tells me the height. That's the distance it's drilled. The height is negative 147.5. That's where it is. Do I know the rate? Yeah, it's still this negative 2.5 feet per hour. Since this one is decimals, I think I'm going to write this one as decimals, negative 2.5 feet per hour. And I don't know the time. It asks how long has it been running. That's what I don't know. So 2.5 times something gives me this. A negative times a what is going to give me a negative. A negative times a positive is going to give me a negative, which makes sense because my time should be a positive amount of time that drill has been drilling. All right, so I know my time at the end is going to be some positive number. And what is my time units? Is this seconds? Is this days? What is this? What was my rate here? Feet per hour. So my time is going to come off in hours. So a positive number in hours. I don't know 2.5 times this right now, but I can work backwards and say, well, it's got to be 147.5 divided by this 2.5. I can work backwards and figure it out that way. So here's where our long division comes into play. 147.5 divided by 2.5 is what we would do for this. Right? Sometimes it's easier to start off like this too, 147.5 divided by 2.5. And technically it's a negative divided by a negative, but we already said that it's going to be a positive right there. Okay, so I'm going to make this a little bit easier for myself and not deal with decimals. I could multiply the top and the bottom of this fraction, really, by the same thing and take away the decimals. What if I multiplied them both by 10? It doesn't change the value, and in doing that, do you know what that does to these decimal places? It takes it away. 10 times bigger would mean no decimal point for here. And it would make these numbers 1,475 divided by 25. And I can do that, and the decimal points go away, and then it makes it a little bit easier for my long division. So this is a little review if you guys haven't done decimal long division in a while. So really these numbers now are just how many times does 25 go into this big number? So 25, does that go into 1? How many times does 25 go into 1? No, 0. So nothing goes up there. How many times does 25 go into 14? Does it? No. Does 25 go into 147 though? Sure, it goes into 104 times. 25 times 4 is 100. And then I can get another 25 in there, but I can't get a sixth one because that would be 150. So 5 times 25 was 125, and that's what I'm going to subtract away. Do you remember our long division? If I subtract it, 7 minus 5 is 2, 4 minus 2 is 2, 1 minus 1, 0. So I get 22 left, and I still have this 5 to bring down. So how many times does 25 go into 225? Does that go in exactly? It would go into 200 4 times. It would go into 100 4 times. It would go into 200 another 4 times, so 8 times, and then another 25. So 8 plus 1, it goes in 9 times. And that's our final answer because it went in exactly. So our answer is 59. It's been drilling for 59 hours. Let's see if that makes sense in the context of this problem right here. If it was drilling for 24 hours up here, it went down 60 feet. So if it's already down at negative 147 feet, it's got to be more than 1 day at least. It's got to be more than 2 days, because that would be 120 feet. So yeah, we're definitely there. It's going to be in the right ballpark. All right, last little thing. We've talked about this, D equals RT, being a proportional relationship, right? If we had to write an equation for this, y equals kx, where k is that constant of proportionality, the constant rate, the constant speed. What's our constant for this one? It's our rate, negative 2.5. So this is going to be, if we graph this, it's a straight line, it's through the origin. The only difference between this one and ones we practiced in the proportional relationships unit is that this is a negative. So instead of being in this direction like we're usually used to seeing, if it's got a negative constant, it's going to be going down, something like this. And I'm just going to make sure right now that my graph is a straight line through the origin. We could get the exact numbers on there, but we're just talking about the general idea right now. As long as we know it would be going down because it was going negative. In reality, positive amount of time, down underneath the ground. All right, I'm going to let you guys go and do the next activity. You're going to watch a video on one more set of problems for this unit, and then we're going to be done with the packet. Woo! All right, I'll see you later.